Hello everyone, welcome to today's class. We'll be starting with a new topic, that's 3D, one of the most important topics, kind of like application to the vectors. So vector and 3D go hand in hand. Okay, so whatever we have learned in vectors now will be applied in 3D. We have talked about direction ratio and direction cosines. So the first topic that I'll talk about in this chapter in order to understand line is first of all direction cosines and direction ratio. Okay, so let's start. Okay. Direction cosines and direction ratio. Let's look at our diagram. One second. All right. So let's look at this diagram. So this time L is your line. Okay. It's in 3D. So x-axis, y-axis, z-axis. Okay. It's making some angle with it. Okay. With x-axis, with y-axis, with z-axis. What is the angle? The angle is cos alpha. Sorry, alpha with x-axis, beta with y-axis, and gamma is the angle with z-axis. Okay. So if I want the direction cosine of this line, I'll simply say, if you give me the angles, I can find direction cosines. Direction cosines, first of all, they are being represented by L, M, and N. Okay. And I can directly calculate if you give me the angle. How? L is cos alpha, M is cos beta, N is cos gamma. Okay. And what is the relation between L, M, and N? L square plus M square is equal to L square plus M square plus N square is equal to 1. Okay. So any line making any angle with x-axis, y-axis, z-axis, we can use it to find the direction cosines. So basically direction cosine indirectly gives us the orientation of the line. Okay. Second thing is the relation between L, M, and N. So if we know two angles, we can find the third one. Okay. All right. Now as such, if we go through the basic point, what were L, M, N? For any line, you will have some sort of direction. We will call that direction as B vector. Okay. So line must have a direction in which it will go. So we will call that direction as B vector. Okay. Now the notation is slightly complicated, slightly. The reason is because it's written like this. So sometimes it's confusing what is B and what is B vector. Okay. I'll try to follow the notations of the book that they use. Okay. If I had the freedom, I would use B1, B2, B3. But the book says like this and the formulas are written also like this. So in order to make that simple for future reference, now understand what's our B vector. Okay. So your B vector gives direction of a line. Okay. And it's a vector. So it will be written like B1 I cap, B2 J cap, B3 K cap. Instead of B1, B2, B3, I'm saying A I cap, B J cap, C K cap. Okay. Remember that B vector is something else. B, A, B, C are some numbers. Okay. This is where it starts to get confusing. Okay. So B vector is AI, BJ, CK. Okay. Anyway, ABC are components of this direction vectors. Okay. Now, if I asked what is the direction ratio? Okay, direction ratio of line. Direction ratio means basically component of your B vector. Okay. If I say find the direction ratio of line, indirectly I'm saying find the component of B vector. The meaning is component of B vector, and what are the components? A, B and C. Okay. If I ask you to calculate direction cosine of it, okay, direction cosine of line. So one way I've already taught you how can you calculate direction cosine if you know the angles between them, the line and the XYZ axis. But what if it is not given like this? What if only B vector is given? Still you can calculate. Basically it's, I'll say, component of B cap vector. So what do? You generate a vector that is B cap. How do you generate B cap? Okay. So for simplicity, let's create some space here. Okay. This is our B vector. Now how can we generate B cap? B cap will be B vector divided by its magnitude. So basically A upon square root of A square, B square, C square. Okay. Plus this is I cap, B upon square root of A square, B square, C square, J cap, C upon square root of A square, B square, C square, K cap. Okay. So these components, this one, this one, this one, though it's looking complicated, they are direction cosines. Okay. So if you try to learn this, it's your call. I'm not saying that you cannot learn this. It's just that learn it like this, that they are component of B cap vector, means you generate a B cap vector. Okay. And then its components, or basically its direction ratios, are called direction cosine. Okay. B upon square root of A square, B square, C square, C upon square root of A square, B square, C square. Okay. Sometimes it is written like plus minus also. So if you actually try to derive it, I have given you a simple definition here, but if you try to derive it, because of the square plus minus comes, right now don't focus too much on this plus minus. Okay. The reason is that if you try to calculate angle between any two things, okay, two lines, if I ask you to calculate angle, you will calculate one angle as alpha, acute angle, and another one is pi minus alpha, that is obtuse angle. So for obtuse angle, your cos of that angle will come negative. That's why it is written plus minus. So don't emphasize too much on that. The point is component of B cap vectors are this direction cosines, okay, and they are also the same thing. This is L, this is M, this is N. Okay. Now I'm putting a box on this. Yes, this is a formula, but don't try to learn it as it is. Okay. All right. Pretty much that's all we need in direction ratio and direction cosines. Okay. Also we need like distance between 2 points will be required, some 3D basic 3D. Okay, so what is the distance formula for say 2 points in 2D? x2 minus x1 plus x2 minus x1 whole square plus y2 minus y1 whole square. So same thing here on 3D also. So same formulas, all those formula of grade 10th. Okay, section formula, distance formula, everything is same. It's just that now z will be introduced. Distance formula, I'll show you how does it. x2 minus x1 whole square, okay, y2 minus y1 whole square, z2 minus z1 whole square. Given that you have 2 points x1 y1 z1, x2 y2 z2. Okay, say p and q. So this is x1 y1 z1, x2 y2 z2. You subtract x components, y component and z components, square them, add them, take the square root, you'll get the distance. This is grade 10 formula in 2D. Now in 3D, just add one. Okay. Same thing you can do with section formula also. I'll write it. So for section formula was done in vectors also. Okay, so I'm talking about only internal division, like 2 points x1 y1 z1 x2 y2 z2. They are being divided in some ratio m1 ratio m2. Okay, and you need the coordinate of this point x y z. Okay, so your x is m1 x2 plus m2 x1 upon m1 plus m2. This is grade 10 formula, no? m1 x y1 plus m1 y2 plus m2 y1. Okay, the idea is like whatever the ratio is, you multiply the first ratio with the second coordinate, second ratio with the first coordinate. Okay, upon m1 plus m2. This will give you the coordinate of this y. Then z, same thing extended in 3D, m1 y z2 plus m2 z1 upon m1 plus m2. So if nothing new as such, yes, these are also again formulas, but are they really formulas? No, these are nothing new as such. This is same thing. Okay, midpoint formula I'm not discussing. Midpoint formula you already know, x1 plus x2 by 2, y1 plus y2 by 2. Now in 3D it will be z1 plus z2 by 2 also. Fine, I'll write it, otherwise you'll say that it was not covered. So fine, midpoint formula also. Midpoint formula. Okay, 2 points x1 y1 x1 y1 z1 x2 y2 z2. You want the midpoint, that's x y z. Okay, so x is x1 plus x2 by 2, y is y1 plus y2 by 2, z is z1 plus z2 by 2. Okay. All right, midpoint formula done, distance formula done, section formula done. That's it. The application comes in real 3D that will start. Okay, so let's first discuss few simple questions on direction cosines. Okay, because I am not sure why, but students have the tendency to look at the word and judge it's a tough concept. So usually if you study 3D, you have the tendency to forget about this direction cosine, though it's very simple, but still. Let's see. I've already highlighted the key points. This time angle is given. So if angle is given, what do you have to use? What is direction cosine? Direction cosines are L, M, N. And if angles are given, I think everything is pretty straightforward. L is cos alpha. This is alpha, beta, gamma, x, y, z. So that's cos 90. What's cos 90? 0. M is cos beta, that's cos 60, that's half. N is cos gamma, cos 30 is sin 60, which is root 3 by 2. As simple as that. Okay. We can think about like this, directly or indirectly, this information gives us B vector. Okay, not exactly B vector. See, what was B cap? B cap was direction, this, once again. Okay, didn't I mention this? This is L, M, N. So basically your B cap vector is L I cap, M J cap, N K cap. So if you know L, M, and N, basically you know your B cap vector. B cap vector indirectly means B vector. At least you know the direction in which the line will go, na? That's very important. So remember that if you know your L, M, N, you indirectly knows your B vector or the direction of the line. Basically, what is B vector or B cap vector? What is this? Direction. So we know the direction of line in which this line is. So that's L times I cap, M times J cap, N times K cap. So another way to give the information regarding the line indirectly, what they can do, because this will be required later on, okay, when we'll do the formats, this will be required. So anyway, this is 0I plus half j plus root 3 by 2 k. Though this was not asked, but still we have found it. The b vector, the direction of line. Okay. All right, simple enough. Next thing is it is saying that if a line has ratio 2 1 minus 2 direction ratio. So again, look at the direction ratio that we discussed. It's component of your b vector ABC. Okay, so direction ratios are given. This is A, this is B, this is C. So basically your b vector is 2I minus 1j minus 2k. Okay, either they can give you direction ratios, that is, again, ratio means I, j, k components basically here. Okay, or they can give you direction cosines also, that will give you again direction but of unit vector b cap. He is asking for direction cosine. Either convert this as b cap and then write the component, or you can do this directly with the formula also. Students have the tendency to go for formula because it's easier. Plus minus a upon square root of a square b square c square plus minus b upon b a square b square c square. Okay. So yes, you can use this, but I will not. Okay, you can literally use this directly and you'll get the value of lmn. Okay, but I am going to with this idea that direction cosine means component of b cap vector. So what's b cap? 2 upon magnitude of this. Let's calculate the magnitude first. Magnitude is square root of 2 square plus minus 1 square plus minus 2 square. Now after studying vectors, you should be comfortable with this. Otherwise, this might, if you're directly doing 3D, you'll get confused. What is how we have calculated magnitude directly. So 2 square 4, 4, 8, 9. So basically 3. So 2 by 3 I cap. Okay. B cap means we have to divide by magnitude. So minus 1 by 3 j cap minus 2 by 3 k cap. The components of your b vector b cap are your element. This is L, this is M, this is N. So write down L is equal to, L is equal to 2 by 3, M is equal to minus 1 by 3, N is equal to minus 2 by 3. Okay. All right. Let's look at another question. This time the question says find direction cosine of a line passing through 2 points. Although this concept will be again discussed, but let's discuss it here also. This time he is giving you 2 points. Okay. We don't need this, we just need this. All right. So you have 2 points. I'm randomly marking them. Okay. Minus 2, comma 4, comma minus 5. Okay. And 1, comma 2, comma 3. Okay. Let's call this as P point. Let's call this as Q point. Okay. Now that you have 2 points, see the line passing through it will be like this. So if I ask you what is the direction of line, will you say it's from P to Q or Q to P? Your call. Won't make any difference. But for simplicity, let's take PQ. Okay. How do we calculate PQ vector? Remember, Q vector minus P vector. This is again from vectors. So Q vector minus P vector. So subtract x component with x, y with y, j with j. So 1 minus minus 2, you'll get 3i. 2 minus 4 minus 2j. 3 minus minus 5, so plus 8k. Okay, and direction of line, we represent this for our understanding by b vector. So now you have a b vector. He is asking again for direction cosines. Can you convert this into a b cap vector and look for the component? Simple as that. Calculate first of all your magnitude of b. So that's square root of 3 square plus minus 2 square plus 8 square. 64 plus 4, 68. 68 plus 9. Weird value. 77. Anyway, let it be 77. So your b cap vector will be vector divided by the magnitude, means each component will be divided. 3 divided by root 77 I cap minus 2 divided by root 77 j cap plus 8 divided by root 77 k cap. Okay, and again the components of your b cap vector are your direction cosines L, M, N. Now I'm not writing this as an answer, but separately you can write L is equal to M is equal to N is equal to. These are direction cosines. That's it. Okay, fine. All right, let's look at a slightly conceptual question. Very good as such for MCQ. All right. He's saying find direction cosines of x-axis, y-axis and z-axis. So what's x-axis? Okay, let's roughly draw this. I think we have this as an option. Not like this. Okay. Let's draw like this. Okay. Again, it's not necessarily where I'm drawing this. X-axis, let's say y-axis. So this is like a plane. This is the ground on which you're sitting or your floor. This is like height z. Okay. Now the point is, if you talk about x-axis, in order to find the direction cosines, now we'll think about here the angles. First of all, we'll not directly think of a vector direction because it's difficult to judge, or would it be? I'll teach you both ways. There are two ways to do this. Okay, let's learn from angle point of view. I'll solve first of all for y because it's easy to see this. Okay, so if you look for y-axis, what is you have to think for angle with x-axis, y-axis and z-axis. So y-axis, what is the angle between x-axis and y-axis? This angle, 90 degree. What is the angle of y-axis with itself? Okay, this is the y-axis. What is the angle of this y-axis with itself? 0. Sorry, 0. And gamma is angle with z-axis. So what is the angle of y-axis with z-axis? Again 90. Do this for x-axis as well as z-axis. So x-axis again with itself it will have 0 angle. With y it will have 90. Z-axis it will have 90 degree. X and z-axis 90 degree. Same thing here also. Z-axis will have 90 degree with x-axis, 90 degree with y-axis, but with itself it will have 0 degree. If you can understand this, I think elements are very simple. Y-axis, x-axis. Why I'm writing this again? L, M, N. L is cos alpha. Cos 90 is 0. Cos beta 1. Cos gamma again 0. So 0, 1, 0. x-axis cos 0 1, 90 is 0, cos 90 90 is 0 0, cos 0 1. So these are the direction cosine: 0 1 0 for y-axis, 1 0 0 for x-axis, 0 0 1 for your z-axis. This was from angle point of view. You can explain the same thing with the help of the direction. Okay, what is the unit vector along x-axis? What do we represent? A unit vector along x-axis. It is represented by I cap. That's the meaning of I cap, a unit vector along x-axis. Okay, so I cap means unit vector along x-axis. And what are direction cosine? Components of the vector b vector, or the direction of whatever you want to calculate. Suppose you want to calculate direction of cosines for x-axis, so you need to look for a component of it. What is the component of it? It's I cap. So for x-axis, I'll rewrite this as 1 I cap plus 0j plus 0k. Again, this is LMN, component of unit vectors. So you see, again, what is the answer coming here also? 1 0 0, same thing. So you can think from direction vector also, or you can think from angle point of view also. For y-axis, same thing. Y-axis will be 0i plus 1j plus 0k. Again, that's your LMN. Z-axis, you will have 0i plus 0j plus 1k. So that's your LMN, 0 0 1. Okay. So from this point of view, you can also think. From angle point of view, you can also think. Whichever you want like. Okay. Fine. We have thought about this now. All right. Now let's start with lines. Okay, this is enough about your vectors. I think direction cosine. I mean, from direction cosine, I think one question is there. Once again, let me see. One more question. One question is there. Do this last kind of question. Now angle you have done, direction cosine, everything is done. The question says find the direction cosine of a line which makes equal angle with coordinate axes. So you don't know what is the angle, but it is making equal angle. Okay, so let's say the angle that is made with x-axis is usually alpha, and with y-axis beta, and z-axis is gamma. So as per the question, it makes equal angles. That means alpha, beta, gamma are same. If alpha, beta, gamma are same, that means cos alpha, cos beta, and cos gamma are also same. That means cos alpha is L, cos beta is M, cos gamma is N. That means L, M, and are same. Now how can we find the value of it from this condition? We know one relation, that L square plus M square plus N square is equal to 1. So all of them are equal. So I can take the values x square plus x square plus x square, all of them are equal, is equal to 1. 3x square is equal to 1. X is equal to plus minus 1 by root 3. That's your LMN. LMN can be 1 by root 3 also, 1 by root 3, 1 by root 3, 1 by root 3, or minus 1 by root 3, minus 1 by root 3, minus 1 by root 3. Okay. Fine. That's all about your direction cosines. Okay. Now let's start with vectors. Let's start with straight line. Okay. So now there are formats as such. Okay. So let's go through those formats. One second. Okay, so one second, I need to move this here. So we are starting with the new subtopic, that's lines. So this time we'll see how a 3D equation is written for straight line. Okay, so straight line so far we did in grade 11th, that was for 2D. This time it's 3D. He's saying first of all you have to learn the formats with the condition. He's saying equation of a line passing through a given point. We'll call the given point as A. Okay, A vector, whose coordinate will be, let's say, x1, y1, z1. Okay, we'll know this one, and parallel to a given vector B. I told you that the direction of line will be given by B vector. So either it will be given parallel to a given vector, or it will say direction of line, that is also B vector. So language can be manipulated, but idea is still the same. The format is R vector is equal to A vector plus lambda times B vector. Lambda is some perimeter. Okay, some perimeter I'm saying, some parameter. It can have any value right now. We are not worried about that. Okay, as such, while writing the equation, we'll not be calculating the value of lambda. We'll write in terms of lambda. This is pretty much like if I ask you to write equation of a straight line, what do you say? Let's say 3x plus 4y, okay, is equal to 5. You never say what is the value of x and y. You'll only say that whatever is the point will satisfy this equation. Same idea, instead of x and y, now you have lambda. So whatever is a point, it will satisfy this equation, and you will have a different value of lambda. That means for every single point you will have different value of lambda. Let's say lambda equal to 1 is this, lambda equal to 2 is this line, this point, lambda equal to 3 is this point. So all the points on the line will have different lambda on it, but equation of line will be like this: R vector is equal to A vector plus lambda B vector. Okay, this is the vector form. Okay, you have to understand Cartesian form also. Vector form, this is a Cartesian form. Now Cartesian form looks big. The problem with the Cartesian form is that only that it always looks big, and it makes the expressions look complicated. Vector makes it look so simple. In the Cartesian form, it's looking like this. Cartesian form. X minus x1 upon A, y minus y1 upon B is equal to z minus z1 upon C. And you'll think, where is this ABC coming from? What is the x, y, z1, x1, y1, z1? And now where is the lambda? They are equal to the lambda. Okay, although the format is this much only, but the point is, where is lambda? They are all equal, and they are equal to the lambda. Okay, what you have to remember for this is the key point to remember. Usually formats are learned, but you forget what is x1, y1, z1, what is ABC, what is A vector, what is B vector. Okay, so remember, A vector is passing point with the coordinate x1, y1, z1, although I have written above also, but still. B vector is direction of the line or parallel vector. And B vector is A I cap, B j cap, C k cap. This is why it's confusing. B I have written here also, B I have written here also. Remember that B vector is direction. A, B, C are some values of it. Okay. It will be much more clear with the help of an example. So let's do question. Let's solve one question. You'll be able to understand it much more clearly. passing to B vector. Let's see a question. All right. The question says that you have to find vector and Cartesian equation of line. They can give you anything. You should be comfortable with both. Vector form is very easy. First of all, your passing point, that's your A vector. In order to convert this in vector, you introduce ijk with 5, 2 and minus 4. B is already in the vector form, so B vector. Okay. So this is your B vector, but B vector is AI, BJ, CK. What are ABC? Components of your B vector. You can learn it like this also. What are ABC? ABC are components of B vector. All right. Now we have A, we have B. I think vector equation will be very simple to write. So R vector is equal to A vector plus lambda times B vector. A is 5i plus 2j minus 4k, that's it, plus lambda times B vector is 3i plus 2j minus 8k, and that's it. You don't have to do anything else. This is the representation of equation of a line in vector form. So vector form is easy. All you need is A vector and B vector. Now Cartesian form, this was vector form. Cartesian form requires the points and your components of B vector, and equation is in terms of x, y, z. Okay, so x minus x1 upon A, y minus y1 upon B, z minus z1 upon C. Rather than learning it like this, what is this? Try to learn this. What is the in numerator? Minus, minus, minus. What are these? Passing points. Passing point we can see from here. Okay. Passing points are in numerator. What are ABC in the denominator? Components of B vector in denominator. Components of B vector. So passing point was x minus 5, y minus 2, z minus minus 4, so 4 upon B vector component 3, 2, minus 8. That's it. Okay. X minus passing point, y minus passing point, z minus passing point upon components of B vector, B vector, B vector. Okay, ABC basically. All right. Next, let's look at a equation, another form. This time we'll take 2 points. Okay. The equation of a line passing through 2 points, not 1 point. Okay. All right. Again, notation has some problem in it. This time B has some different meaning. Okay. Again, I'll try to simplify this. This time you have 2 points, A point and B point, and you have to write the equation of a point, equation of a line passing through these 2 points. Okay. So your A vector. Okay. So one passing point A is x1, y1, z1. B point is x2, y2, z2. Okay. Again, if I ask you what is the direction of line, now this was already discussed in direction cosine. I can say direction is from AB. Okay. So I can say direction of line is AB vector, which is basically B vector minus A vector position wise. Okay. This is normal vector, basically I'm doing this. The position vector of B vector minus position vector of A vector. AB vector is B minus A. Now if I tell you that write a equation of a line whose passing point you already know and direction you also know, isn't this same format? R vector is equal to A plus lambda times B vector. So for this equation, so for this one, my suggestion, you learn only the vector form. I'll write the Cartesian form, but I'll suggest that you don't learn the Cartesian form because it's lengthy to learn. Okay, vector form is easier to learn for every format. I'll write the Cartesian form, but I'll again suggest which one to use, which one not to use. For this, both to be learned. For this one, we'll do only vector form. So this time I'll say R vector is equal to passing point is A, so A vector plus lambda times direction. Now what is direction this time? AB vector. So that's A vector plus lambda times B minus A. Okay, that's the vector equation. So vector form. Okay, A vector passing vector plus lambda times direction. Direction is this time AB. It was not B. This is where the confusion is created. Earlier B was directly direction. Here B is the passing point. Okay. So how do you learn the format? You learn the format like this. R vector is equal to passing point plus lambda times direction. Learn it like this. The vector form is this. So now let me show you the Cartesian form also. Cartesian form is x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. But my suggestion, again, don't try to learn this. If you know how to write this, you can easily convert vector form to Cartesian form using the above concept that I taught from this. That how to write, if you have this equation, suppose you have already written the equation of a line passing through 2 points. This is the equation. So if I ask you to convert into a Cartesian form, what do? Right now consider this as your passing point and this as your components of B vector, which is in the denominator. I'll show you with the help of example why that is useful. The question says to find only the vector form, but I'll find both vector and Cartesian form. I'll not use this format, rather than I'll convert vector form to Cartesian. This is our A point, this is our B point. Let's calculate first of all direction of line. That's AB vector, basically your B vector minus A vector. So let's subtract 3 minus minus 1, 4i, 4 minus 0, 4j, 6 minus 2, it's coming 4, 4, 4, 4j, 4k. Okay. You have a passing point, no? So how can you write this? Now R vector is equal to A vector plus lambda times, I will learn like this only. Okay, don't write B minus A vector, write direction. A vector is passing point, B vector is direction, lambda times direction. So A vector is just ijk along with it, so minus 1i plus 0j plus 2k. Okay, plus lambda times AB is 4i plus 4j plus 4k. Suppose the question was asking, apart from your vector form, it was asking for Cartesian form also. Now how does Cartesian form is written? X minus passing points y minus passing point, z minus passing point. So what is the passing point? Let's take a as the passing point. We can take b also, that will also be correct, but still for simplicity let's take a. So x minus minus 1, so x plus 1, y minus 0, z minus, what is this, 2, upon what is the components, what are the numbers a, b, c below? They are the components of your p vector. This is your b vector. Now it will create confusion. Components of b vector or components of direction of line. Components of direction of line. So this is the direction of line. Their components will come in the denominator 4, 4, 4. That's it. If I say no direction or components of b vector, so you might think I have to take 3, 4, 6. No. Whatever the components of lambda factor is there, that will come in denominator. Passing point is the first one that is written. You write it in the numerator with subtraction. X minus minus 1, y minus 0, z minus 2. Okay. All right. You can do the reverse also. Suppose a Cartesian equation is given. So conversion of equation should be pretty much clear. Whether a vector form is given, you should be able to convert into Cartesian. If Cartesian is given, you should be comfortable to convert into a vector form. Let's see. If we compare it with this, x minus x1, y minus y1, z minus z1, upon a, upon b, upon c. Basically numerator, whatever is written in the numerator is your passing point. Denominator is direction of b vector, sorry, direction of line or component of b vector. So clearly I can say your b vector is 2i plus 4j plus 2k, and a vector you have to change the sign, whatever is written, because it's x minus x1, no? So a vector is, change the sign, minus 3i plus 5j minus 6k. Okay. Remember to change the sign. So now vector form is a vector plus lambda times direction. Okay. Pass. So minus 3i plus 5j minus 6k plus lambda times 2i plus 4j plus 2k. Okay. You have to do the reverse if it is asking to convert into Cartesian form. Okay. So this one, passing point in the numerator with sign change, x minus x1, y minus y1, z minus z1, and denominators are component of lambda or components of your direction vector. All right. Now let's talk about angle between two lines. Again, the formula, this one though I'll just give you the only vector form formula. The Cartesian form formula is absolutely ridiculous to look at. Next form, not exactly form, next is two lines are there, let's say. So how to calculate angle between two lines. So let's say you have a line 1, that is r vector given by a1 vector plus lambda times b1 vector. A line 2 will be given, okay, like this. And even if it is given in Cartesian form, you convert into a vector form. Okay, so the conversion of one form to another one is very much important. A2 plus, let's say, mu. Okay, either I have to take lambda 1, lambda 2, or I have to take lambda and mu or something, some other alphabet, b2. Okay, let's say this is the equation. See, if we really want to know the angle between two lines, does the passing point has any effect on it? Whether one point is here, another point is here, does it really have effect on this theta or the point or here? Would it really affect the theta? No. Then which thing will actually affect it? Basically your direction. Okay, your direction of this line, because the angle is created because of this direction of L1 and L2. So a simple point is angle between lines is equal to angle between their B vector. So if I ask you to calculate angle between two given vector, what do we use? We use cos theta is equal to dot product of those vectors. So B1 dot B2. So angle between their B1 and B2 basically. Okay. So dot product divided by their magnitude, mod B1 mod B2. Okay. Now you don't have to remember this as a separate formula. You can only remember this line. Angle between line is angle between their B vectors. And how to calculate angle between two vectors? You already studied that in vector. Cos theta is equal to dot product divided by their magnitudes. Okay. If you really want to look at the Cartesian form, I'll paste it. It looks weird, absolutely weird. It looks like this. This is the Cartesian form. Look at the expression in vector form, look at the expression in Cartesian form. Although meaning is same, but it is looking absolutely rubbish. So no need for this. Keep it simple. Now if we are talking about angle between two lines, so again special cases can arise. What are the special cases? First special case, if two lines are perpendicular, then what can we say? The dot product is 0. If two vectors are perpendicular, then dot product is 0. So in this scenario, if two lines are parallel, then the B vector or the direction vectors of the lines, dot product should be 0. And if two lines are parallel, so what is the condition of parallel? Two vectors are parallel if A vector is lambda times B vector. Here B1 and B2 are there, so B1 is equal to lambda times B2 vector. Okay. Or we can say the components are in ratio. Okay. So I'm not writing the whole expression for that, just this. Let's do a question. One second. Yes. Look at this question. You have to find the angle between two lines. Okay, two pair of lines are there. Again, the first component is a passing point. No need for this. We have to focus only the direction of line B1 vector and B2 vector. Angle between line is angle between these vectors. So cos theta is equal to B1 dot B2 upon magnitude of B1 magnitude of B2. So everything will be done here. Dot product, let's do 1 and 3, 3, 2, 2, 4, 6, 2, 12, 12. This is the dot product. Magnitude of A vector, sorry, magnitude of B1 vector, 1 square, 2 square, 2 square, 4, 4, 8, 9, so 3. This is 6 square, 36 plus 4, 40, 49, so square root of 49 comes 7. Okay. So that comes 15 plus 4, 19. 19 by 21. So we can say theta is cos inverse 19 by 21. Yes, weird value, but we cannot solve it any further. Okay. Now suppose they want to slightly complicate things. What they'll do, what they can do is give the equation in Cartesian form. So now the equation is in Cartesian form. Same thing. Again, we have to find only the B vector. Where is the B vector, or where is the direction of the line? Direction of lines are the components here. Okay, this is the direction of line, or our B1 vector. This is B2 vector. So I'll write B1 B2 first, because x minus x1, y minus y1, z minus z1. Numerator has passing point, denominator has direction it. So B1 vector is 3i plus 5j plus 4k. B2 has 1i plus 1j plus 2k. Okay. All right. Now same thing, cos theta is equal to b1 dot b2 1 mod b1 b2. So b dot product is 3 plus 5 plus 8 upon magnitude is 3 square 9 16 25 25 550, so root 50, and next one is coming 2 square 4 plus 5 plus 1 6, again weird kind of value, 8 5 13 16 by 5 root 2, and this is coming root 6. Let's further simplify, 16 by 5, this can be written as root 2 into root 3, so 5 into 2 into root 3, so basically 8 by 5 root 3. So theta means cos inverse 8 by 5 root 3. See, solving this will not be difficult if you are comfortable with the basics of vector, dot product, cross product. Okay. You will not get stuck here. The only problem with 3D is identification. Where is your directions? Where is B vector? What is A? What is B? And the problem is the meaning of B changes. So most of the time B is your direction only in angle between two lines. Remember that there is AB as your direction. Okay, B is not the direction. All right. Then comes a straight format. Let's finish basic of this first. Next is called distance between skew lines. Let me get the heading first. Okay. Now the problem is, first you have to understand what kind of line is this. The problem is this is in 3D, so I'll not be able to draw it properly. Okay. There is a figure given, but it doesn't make any sense really. Okay. So what I'll do is, yes, try to look at my camera. See this kind of line here. This line and this line, they are not parallel. They may intersect. The point is they can intersect, but point is they are in different planes. So they are not parallel. They are not still intersecting. Now these kinds of lines are called skew lines, and this happens only in 3D. In 2D, if two lines are at some angle, they will always intersect. But see this, I have displaced it above. Now they will never intersect, and they are not parallel also. These lines are called skew lines, and we have to calculate the distance between them. So this is again, so as such there are two lines. Okay, so we only need equations. Visualization is slightly tough in 3D, so all we really need is equations. So although the diagram is given like this, really won't mean anything as such. Okay, it confuses you sometimes that why is this distance, why not this is this distance. See, there is a minimum distance between two lines. This is that minimum distance, and the distance is given by, there's a long format. D is equal to B1 cross B2. Okay, what is B1 B2? This is line L1. So line L1 is given by R vector is equal to A1 plus lambda B1. This is R vector is given as lambda plus mu B2. Okay, so all you really need is A1 B1 A2 B2. If you have that, you calculate magnitude of B1 cross B2, then do the dot product with A2 minus A1 upon magnitude. No, sorry, my bad. First you calculate cross product. Okay, then you calculate its magnitude, then you calculate then you do the dot product with A2 minus A1. Okay, so I'll write in steps how to calculate. You calculate first of all your B1 cross B2. Second, you calculate B1 cross B2 magnitude, and then you do B1 cross B2 dot product with A2 minus A1. Okay, then you calculate its mod. Why it is mod? First of all, dot product results in a scalar, denominator is also magnitude, so it's a scalar. Then why mod? Because the dot product can result in a negative quantity, so in order to avoid that, distance is always positive, this is mod. Mod is for actually making it positive. Okay, the Cartesian form, again, absolutely ridiculous, no need to even look at it. This is it. Okay, so if the vector equation form, vector form is given, good enough. If Cartesian form is given, you convert into vector, identify your a1, b1, a2, b2, that's it. Okay, we'll look at the question. First, let's look one more format, distance between two parallel lines. Okay, so you have two lines which are parallel. Parallel means they have same direction, means they have same b vector. So I'll say my line 1 has r vector is equal to a1 plus lambda b. Okay, r vector for L2. Okay, for line 2 I have r vector as a2 vector plus again some mu b. Okay, b is important, b vector, both should have same b vector or proportional as such. Now in order to calculate this distance, this is the distance between them, TP is represented. How do we calculate the distance? It's again given by with the help of cross product and the magnitude, closely related with the previous formula. You can see like this. This time it is doing b cross a2 minus a1. This is not dot, this is cross product, b cross a2 minus a1 upon magnitude of b, and then again a mod. That mod makes the distance positive. That's it. Okay, so put a box in it. All right, put a box here also. Erase, erase, erase. Let's look at two questions based on each idea. If the question says find the shortest distance between two lines, by default assume they are skew lines. If the question says the lines are skew, he is asking for the distance, that is distance between skew lines. Okay, this time he is not saying the lines are skew, but you have to understand shortest distance between two lines means the lines are skew. Okay, so this is your a1, that's your b1, this is your a2, that's your b2. Use the format. Okay, step 1, calculate b1 cross b2. So ijk, slightly lengthy, but yes, 2 minus 1 1, 3 minus 5 2. We calculate this. Okay, then second thing you calculate is your magnitude of b1 cross b2. Again, that can be done only after you calculate your b1 cross b2. Okay, so what is this coming? 2 minus 1 1 and 3 minus 5 2. It's coming out to be 3i minus j minus 7k. Okay, so you solve this, you get 3i minus j minus 7k. Okay, you can solve this on your own. Cross product we have already practiced. Now you calculate magnitude of it. What is the magnitude? Square root of 3 square plus minus 1 square plus minus 7 square. So 49 plus 150 plus 9, 59, root 59. Okay, now you do dot. First you calculate a2 minus a1 better, rather than doing it directly. First you do a2 minus a1. So 2i minus I, j minus j, 0j, minus k, and there is no k, so minus k only. That's it. Now you do b1 cross b2 dot a2 minus a1 and divide by the magnitude of b1 cross b2. It's lengthy, yes, but This is the exact process. Dot product of these two. So 3 into 1, 3, minus 1 into 0, 0, minus 7 into minus 1, so plus 7 upon root 59 in the mod. You can see the dot product could have come negative, so in order to avoid that, that's why this is mod. So 10 upon root 59, that's the distance between these two lines. Okay, let's do the last format question, distance between two parallel lines. So for parallel lines, all you need is A and B, A1, A2, and you can see both have the same B vector, so lines are parallel. Okay, the moment I see both have same B vector, lines are parallel, so I have to use the format of parallel lines. The distance formula is B vector cross A2 minus A1 upon magnitude of B with another mod. Okay, all right. So cross product, B vector is, so I, J, K, B vector is 2, 3, 6, A2 minus A1 is 3 minus 1, 1, 2, 3 minus 2, 1, minus 5, minus of minus 4, so plus 4, it will become minus 1. You calculate this and then you calculate magnitude of B is square root of 2 square, 3 square and 6 square. Okay. So if we solve the cross product, we get magnitude, another mod is there. Okay, anyway it's distance, so we effectively have to calculate the determinant, or we have to calculate the magnitude. Okay, so this is coming out to be minus 9I plus 14J minus 4K. Okay, upon this is coming out to be 36, 40, 49, again 7, same thing. So you calculate the magnitude now of that, again it is coming minus 9 square, 14 square, minus 4 square. So big values, but still 81, 485, 81 plus 196 plus 5 upon 7. So that turns out to be, this is 201, 16, 4, 7, 7, 5, 12 it is coming, 16, sorry, my bad, this is 4 square, no? 4 square is 16, no it's okay, yes, 6, 6, 12, 13, 9, 10, 11, sorry, 9, 10, 8, 11, 19, 293, root 293 by 7. All right, that's your answer. All right, so yes, the formats are lengthy, but cross product, I told you that it will be always lengthy. So usually these kinds of questions are sometimes avoided, but equation of line, they are very simple. Angle between two lines, they are very simple. Okay, so go through the formats, revise these. Okay, we'll discuss some more questions in the next class. That's it for today. All right, see you in the next class. Good day everyone.